Hi, I'm Daza Greenwood, a scientist at MIT Media Lab, and this is a tool tutorial on smart legal contracts with the co-director of the Accord project, Human Shadab. And we're also joined by Mila, the teacher's assistant. Hello, Mila, from Brazil for the upcoming computational law course at MIT, January 15th through 17th, 2019. So if you're seeing this before the course, it's not too late to register and apply at law.mit.edu/learning. So with that, I want to just welcome you and thank you for taking the time to walk us through the Accord project, Smart Legal Contracts, and take it away.
Yes, absolutely. Daza, thank you so much for having me here and to your entire community, as well as Mila as well. I'm looking forward to discussing the work that we're doing here at the Accord Project. So yeah, once again, my name is Human Shadab. I am a co-director of the Accord Project. The Accord Project is a nonprofit organization dedicated to developing open source software and related specifications for smart legal contracts. And with that introduction, I think I should just go ahead and share my screen, if you don't mind. And just quickly walk everyone through a presentation slides to give it a background, and then go to going to an online tool.
Great.
So yeah, so the Accord project is dedicated to making open source software and specifications for smart legal contracts. And I'm hoping everyone can see this slides that are here.
Yep, looks good.
Great. And one thing at the outset, just to distinguish between on a terminological basis, is a smart legal contract versus a quote unquote smart contract that is associated with blockchain technology. And a smart legal contract is something that the Accord project is focused on, and that's the latter definition, which is essentially a legally binding agreement that is digitized, connected to software, has computational terms and conditions that can give real-time status of the performance of a contract, as well as automate various actions, operations, and carrying out obligations of a legally binding agreement. A quote smart contract, confusingly, is often refers to a distributed application that runs on some kind of blockchain or distributed ledger technology network. Probably the best term, though, for those types of things are distributed applications or chain code, as the case may be. So what we're referring to here is primarily smart legal contracts. The Accord project, as I mentioned, it operates in conjunction with a wide variety of law firms and trade associations, including the ones that you see here, and technology providers. And again, the focus is to address lack of standardized standards and technology and open source code in this area to essentially bring a collaborative approach towards going from traditional contracting to computational contracts in a variety of environments. The Accord project is Codebase, or it's online code. It consists of several sort of components, one being the Cicero for templating smart legal contracts, going from traditional contract to some kind of computational representation. Ergo, which is a language, that's specific computer programming language that's specifically made for legal contracts. And then libraries, of course, online libraries to share and contribute to and to modify for the templates and the models and the data representations that are associated with all of the above, as well as tooling that we'll see that make it easier for parties to contribute. And we'll focus on that towards the end. And so in terms of, from a computational point of view, a Accord project point of view, what is a smart legal contract? It is, as we'll see, the natural language text of a contract with variables for things like price and buyer and seller name and their address, and other terms that can be objectively verified one way or another, including with external data. Then once you have those variables that are in brackets that should not be too unfamiliar with the idea of just a general template, then we have taking those variables and putting them into a model. that we'll see as well. So essentially categorizing the variables according to different types or categories. And then finally, you have the code that really says, if this happens, then that happens. So taking that contract logic and creating a execution code for it, and that's what Urgo is. And essentially, that helps to automatically enforce compliance with the contract terms one way or another. In other words, you could have data coming in that says the goods are arrived, but they're broken because there's a sensor, for example, and then that says, okay, well, then the buyer doesn't have to pay for them. The seller has to ship new ones at their own cost, and so on and so forth. So that's what the logic of the contract and the code that captures that is all about. At the Accord project, we like to represent those three aspects of smart legal contracts as the natural language we're all familiar with, the models, which are those variables, both for the objective terms and conditions of a contract, price and so forth, as well as the logic that executes the contract as well. And we'll get into an example of all this too. So maybe wondering, okay, so what does a smart legal contract have to do with blockchain? On some level, the answer is nothing per se. A blockchain, you can look at it as an infrastructure element to computation, which may help in various aspects of carrying out a smart legal contract. And there's really three ways that we view it as being potentially enhancing of a smart legal contract, but not necessarily even required. So in other words, you can, of course, run a smart legal contract without anything that resembles blockchain, but using purely proprietary centralized software. But smart legal contracts can help to carry out a smart legal contract if you want to send data from a blockchain to a contract, and you may want to do that because you consider that data to be immutable or at least tamper resistant or tamper proof because it's being input according to some verifiable process, and once it's on a blockchain, it becomes verified. And we'll see some examples of that. You may want to send data to a blockchain from the centralized contract store of data that says, hey, someone paid or didn't pay, or now they've signed the contract, and they get shot to a blockchain. And you may want to do that for sharing data for some kind of audit trail purpose. If there's perhaps litigation, or just generally speaking, you may have 3 or 4 or 5 different companies in a business network that want to know about when something happened, so they can plan accordingly. You may want to use a blockchain as a type of token or cryptocurrency network for initiating payments or some other kind of transfer of assets, perhaps even real estate. You may also want to use a blockchain to actually execute the logic of a smart legal agreement. And that's essentially what smart contracts in the blockchain sense mean, is running code on many computers and having that code verified. The potential benefit for a legal agreement is to say, well, we know that no one has changed the terms and conditions of the contract, let's say after it's been signed. So we know that the if-then logic is essentially more verifiable, more transparent, because it's running no buyer or seller or party is responsible or accountable for it in that sense, or has control over it. Rather, it's being run on a blockchain network with a wide variety of parties involved. Okay, so let's take a step back again and look at smart legal contracts, again being just a natural language text, but that text then marked up with variables and brackets, then going from there to having the if-then logic of the contract coded up, and then potentially also running the contract on, again, the blockchain like Corda, Ethereum, Hyperledger, or whatever the case may be. So let's look at a simple example here of the late delivery and penalty clause. And what you see here is a traditional contract text, and with the variables here in red. It can take a moment to read that, but the idea here is that if the goods are delivered late, there will be a penalty that is imposed on the seller every 2 days that the goods are delivered late. This is a relatively common clause in a contract that you'll see in oftentimes in international trade. So the next step is just to take that text and just take those red actual deal terms and just turn them into variables. And what we're doing here is first identifying the buyer and the seller and the other aspects of it as being variables, and then actually giving them names that should remain consistent essentially throughout the life cycle of this contract. Just the way computer science has sort of evolved over time is that the first letter will be lowercase. If you essentially make two words out of one variable name, that second one will be capitalized. So penalty percentage, duration, the cap, and so forth. That is those will be you follow that nomenclature. And what this clause also does, of course, is to cap the percentage of how much there's the penalty imposed on the seller, in part due to commercial terms, in part due to the fact that at some point the penalty will be deemed a penalty and not liquidated damages and not be enforceable by a court. And finally, also giving the buyer, saying at some point, even though the damages have been capped, you're delivering the goods so late, I have an escape valve from the contract, the maximum delay, and therefore I can terminate the contract without recourse. Okay, so we have those variables. Now let's look a little bit more at the model aspect of the triangle. And if you look at the way the model works out, is that you take those variables, buyer, seller, penalty, duration, and those 6 variables here in red, and you have to categorize them according to some kind of basic type or category. And looking at the one here, maximum delay, it's a duration category. In computer science, also a type. And in the actual deal terms, it was 15 days. If we just go back to that and look at that, the actual deal term was 15 days, just to show you how the through line through all this. And we can go ahead and see as well for the cap percentage, that was 55% of the purchase price. And that is categorized as a double, which in computer science is 2 decimals past the 2 decimal places, that is. And we can go ahead and do the same with other aspects of the contract. The seller, which is a type of string, which itself has a type of party ID. So in other words, you can construct types out of different, more fundamental types as well. Same thing with duration. What you're seeing here is that the duration type is actually made up of a temporal unit, which is a more basic category that has the seconds, hours, weeks, and years, and so forth. And then also, though, puts the amount of it too. So 2 seconds, 5 years, whatever the case may be. And that's where the penalty duration in this clause is constructed from and categorized by. And finally, in a sense, taking a step back and looking at the bigger picture, you can see again, just we have on the top right here that initial is in a sense traditional contract clause with the actual terms filled out. Just to the left of it, we have the template aspect of it. Again, the template itself should be quite familiar to transactional lawyers or anyone who's just seen a contract template, a form to fill out. And then finally here, what we're doing is abstracting those actual the deal points here, the percentage of the data, the percentage of the penalty, per every 2 days being late, and here's 2 days being late, as well as the maximum delay, the cap percentage, and so forth. And so that is the general smart legal contract template framework. Now, let's take a look at the execution logic. So looking at this relatively simple clause, what is the contract logic, the if-then, if you will, of this? It says, see if the goods are late, if the clause applies, apply the penalty formula, but stop at number 3 if there's a cap. And finally, make sure the goods are not so late, but if they are so late past the maximum delay, then the buyer can terminate. So let's take those essential aspects of this clause and turn them into computer code. So one aspect in terms of a conceptual framework is just taking in new data points. So we have to actually take a few more data points, in other words, a few more variables, and say, okay, to know how to execute these 4 aspects of the logic, we need to know some facts about the real world, right? So we need to know, when did you agree to deliver it? When did you actually deliver it? And what was the price? Because we need those data points to know whether they were delivered late, how late they were delivered, and so forth. And so in this case, as the case is from when the goods were actually delivered. They were delivered so late, if you look at the delivered at, over a year late, such that the penalty is the maximum penalty. And because they're delivered so late, the buyer may terminate a variable that's associated with the execution logic is yes. It's a Boolean, it's true. And so we can take that same idea about categorizing the variables that were associated with the model or with a template, and also have variables associated with the logic that we can also categorize. And you see that happening here. But I really want to focus now on the contract execution logic, which basically says, okay, so let's go through those 4 points above, if you recall, and let's see how that's converted into code, which is an ergo. And so you can see that happening here. First to say, does a clause apply? What's the scope, right? The scope of the statute, the scope of the contract, and here's the scope of the clause. And you do some basic definitions, as well as saying request, go get the data from the external world, simple request function. And again, so this, obviously these models are very high level, so that data may come in from an IoT sensor, a platform, a scanner, a carrier's API that says the goods were delivered, right? FedEx or something. So wherever that good comes from, the request, we actually can see when it was the delivery. It was actually delivered at. And then the basic obligation, the contract logic comes from the enforce function. And only if it's late, then we're going to have some kind of calculation of the penalty formula. And that's when part 2 of this comes on. And in a fairly straightforward way, and that's the whole point of ergo, you can see that the goods were how to calculate the penalty percentage if the goods were delivered. And this is basically the formula that applies here. Now, you also want to make sure, of course, that the whatever penalty it is not above the cap. And here's a simple if then else. The cap penalty will equal the function basically says that if the penalty is greater than the cap, then the cap then the cap is the right variable to use or right output. Otherwise, stick with the penalty because it's still below the cap. So if then else should be also quite familiar to attorneys in terms of thinking through the logic of contracts or statutes or any kind of rules. And then finally, in terms of outputting, what's sort of the legal obligation or consequence of this clause? Well, it's a penalty on the seller and or the ability of a buyer to terminate. So here we can have the penalty amount, which is going to be outputted, as well as whether or not the buyer can terminate, and that would be a yes or no. And we already saw that above. The penalty amount there was 110. In other words, 55%, right, of the price of the goods, which was 200. In other words, a maximum penalty, but also because they were delivered so late, the buyer can terminate. And so that's a run through of the Accord Project's framework for smart legal contracts. And finally, you may be asking yourself, well, why do we need yet another language? And the idea is we do need another language for contracts in particular called ergo for the following reasons here. Something that's focused on contract logic, in other words, purposely limited. It's not Turing complete, so it doesn't suffer from potential consequences and anomalies and bugs that complete languages can, including the smart contract or chain code language of the Ethereum public network, which is Solidity, at least the default one. Ergo is also, as you could probably see, relatively easy for a non-technical professional, at least to read through and say, okay, I think it looks like the logic of the code is the logic of the contract is being properly captured by the code. There's no real nothing's being left out here. So obviously for contracts, you want the code to capture the legally binding intent of the written language. Ergo also has a wide variety of more technical properties that makes it less susceptible to bugs and other types of errors as well. And they call those types of things formal verification, where the basic idea is that all the variables in your contract should match up with the variables in the logic so that there's no fundamental runtime bugs that could occur.
So, may I ask, is the
Yes.
formal verification here a, a, a a method that will try every permutation of the way that you could, like, in other words, like every sequence and, valid input type to see if you get any anomalous results, or is it something more, or is it different than that?
Yep, that's correct. Basically, formal verification on this level, and it's certainly quite a technical topic, but yes, it basically checks, and we're going to actually see that in real life, or real time, which is real life, I hope. But we'll see how it checks basically to make sure you've categorized your variables correctly from the outset, as well as consistently throughout your model, as well as you use them correctly. In other words, you're not trying to add letters to each other. You're only adding numbers to each other and so forth. So you're performing the right operations on different ones. And
Awesome.
that brings me to Daza. And so, but it's not a fail safe in the sense that you can, no matter what kind of formal verification properties you have, you can always, for example, you can miscode that formula, right, for penalty delay. There's no stopping human error necessarily like that. On this level of formal verification, but it can reduce substantially, if not eliminate, entire categories of software bugs from happening. So this takes me to the online template studio of the Accord project, and that allows you to make these smart legal contracts using an online editor, downloading the relevant code, and then with a few clicks of a button, uploading it to GitHub as well, without having to go through some of the steps that would otherwise be required and make it a bit more of a hassle, as well as having an online interface to do so. And finally, to have a real-time method of checking your models to make sure they're free of some fundamental errors. So let me go ahead and just pause the sharing for a moment and open up Template Studio.
Just as a quick aside, Mila and I are doing a little back channel here, but this is truly excellent in terms of the themes we've been developing on, what is computational law over the last few years, and last year in particular with Mila in the course. You're hitting a lot of the highlights of what we would define as a computational contract. You're calling it a smart contract, which is completely fine. I think that's makes a lot of sense, and I think that it's a more widely used term for what you mean. Although some people, as you said, do ascribe that meaning to in a limited way to blockchain only. But we would expect to see something where where the legal terms and the machine readable terms, can be equated and managed and drafted by a human, attorney or others, and where, well, formal verification was sort of a stretch goal, frankly, but that you've incorporated it along with a number of the other approaches you said so far is absolutely street legal for our concept of computational law. So kudos.
Yeah, absolutely great. And certainly this is a really exciting project that I think is finally getting to what a lot of people have been discussing and thinking about in terms of computational law for years, if not decades. And certainly it really owes a lot to, and everything really, to the team, the contributors of the Accord project's technology, Dan Selman, Jerome Simeon, and everyone else. It's really, really fantastic stuff. And I'm really just excited to be someone who's involved and learning about it as we go ourselves from more of a legal point of view and technical. But yeah, we're really excited about this, and to that extent, I certainly encourage everyone to get involved and contribute and learn, and as well as critique to and help improve things too. So let's go ahead, and I'll go ahead and share my screen again and go to the online editor quickly, and we can just sort of wrap things up. Let's see, screen share. Okay, so we just saw sort of a slides version of that late delivery and penalty clause. Now what I'm at is the online editor version, which would be a way to create that clause to begin with. You can create a whole contract using this online editor. You can also take that clause change it. Maybe you want to add more variables, different logic, and so forth. And that's where you go to studio.codeproject.org. And what I've done here, I've searched from the list, found that simple late delivery and penalty, because it is relatively simple. There's a more complicated version of it as well. And if you search in this box, it has all the other templates, and those templates are being drawn from the GitHub repository of the Accord project. Okay, great. So it's here. And let me so you see these 4 buttons here on the left. So there's the contract text, and the test contract is the name for the contract with the actual terms. So that's, something that happens every day in practice, nothing new there. But then we take one step again away from that and put the variables in the templates. So we saw that earlier, the same variable names, the same variables we picked. And then we go, so I think we all kind of get it there. Then we go to the model. And this is another representation of those yellow boxes where you saw those categories being given to maximum delay, for example, if you remember, was duration. The cap percentage was a percentage, so it's a double. So you see the models associated with that late delivery penalty clause, as well as some of essentially the preamble, which just basically says that, what file system in GitHub that these models are associated with, and it's a CTO file from the composer, comes from the composer model. Then there's a logic, which is that contract execution logic, and again, that's those 4 points, if you remember. Let's say, okay, those 4 things essentially is what's going on in this clause. If it's late, how late was it? What was the price? So we can add that penalty per every 2 days. That's where this lives. And again, this, by the way, this is all editable. Everything we've seen here so far. And if you edit it, then automatically it's going to throw an error, because it is essentially checking this stuff in real time. Hopefully I can fix it by putting n back. I deleted. What's new about the online editor is that you can actually sort of, once you have your model, besides the automatic checker, you can sort of test it to see what the input output logic is. So you can send this request, and so this is the input data that's coming from the real world, which I mentioned again. When was it supposed to be delivered? When was it delivered? And in this case, it's null because it was never delivered. That's what null would represent. But we could put a date. We can put like December 18th, whatever the case may be. But you'll see, let's say you never deliver the goods. Well, then the penalty is going to be the maximum, as well as the buyer can terminate. And then there's a few more windows here, which tell you a bit more about the contract. The contract state's not too important. It's some baseline data about the metadata, essentially, about the contract. The obligations do tell you, though, essentially what is another way of looking at the output, what's being emitted from a legal sense about the contract, as well. And again, that's telling you some of the deal data. The penalty percentage and the cap percentage, that's part of it as well. And then finally, sort of, what is the amount of the penalty that must be paid.
Great.
And then,
so
yep.
Can I ask, so would this, it seems like this would provide the capability to monitor and manage the contracts as they're being performed. So if you've got, you could see the current state of the penalty, for example, or is that right?
That's correct. Yeah, exactly.
And under state in general, if let's say that the period for performance has been exceeded and the counterparty chose to execute their right to terminate the contract, is there a common nomenclature in this model or template to indicate that the status of the contract is terminated?
Yeah, so that would be right here. The buyer may terminate variable, and that's a Boolean, yes or no, or true or false, and here it's true.
So buyer may terminate, the semantics of that means buyer has terminated, or that they now may terminate.
That they may terminate, that's correct.
If the buyer goes ahead and then chooses to terminate, could you use the template or code it in a way where that action resulted in the state of the contract being terminated.
That's true. Yes, you could add that logic. Yeah, great point. To automatically terminate if it's beyond a certain date. Absolutely.
Okay, great. I'm just trying to track what you're saying as we
Yeah.
go. Sorry to interrupt.
Yeah, no, no, not a problem. That's a great question. And if anyone has questions, by all means, let me know. And you can sort of see what happens if you reset the contract. Let's change the price from 100 to 200. I think even I can do that, and then send the request again, and you can get you'll see that the penalty price has changed. And the point of that is to say that different data coming in will result in different legal obligations coming out, and all of that traces back to, again, and is dependent upon the model, which has a logic telling you what to do and what calculations to apply, as well as the contract text, um, which is where you sort of begin with a lot of those variables. And finally, if you go to the help button here and then click on the documentation, as far as how to get started and what's behind all this stuff, if you go to, and it'll take you to docs.accordproject.org, where you can see the documentation, especially the Cicero for the template aspects of things, the variables and so forth, the Ergo for the execution logic, but really they're bound together, of course, in a smart legal contract. And then it also, what's been done so far, the online repositories for the smart legal contract templates, which I encourage you to contribute to, as well as the models as well. And models are a part of the core project to help and make sure that first you don't have to redefine everything every time, as well as to ensure the interoperability between different systems using this technology. And certainly a goal of the core project is to make this high-level representation and ability to code contracts certainly interoperable across different types of software platforms, including if you compile this stuff or send data to different blockchains as well. And so that brings me to the end of my remarks formally. I'd be happy to answer some more questions and have more discussion as well.
Well, thank you so much. That was extraordinary. And boy, it's come a long way since it's been about a year since I checked in, and it's looking really solid. My question, I guess one question I have is, do you have any advice, or I guess, first of all, off the top of your head, are you aware of any music industry templates that exist already? And if so, where would one find them? And if not, do you have any advice for students in our course or those that come later in terms of how to create a template that would be appropriate for those somewhat unique deal terms?
Yeah, so there is a basic copyright license available on the Accord Project's template library, which may be suitable for that purpose, at least getting started. I would certainly encourage students to sort of join the Accord Project, get involved in terms of maybe going to the working group meetings, or at least just get involved by learning the technology and maybe taking that maybe as an exercise, taking that copyright smart legal contract, copyright license smart legal contract template, and maybe adjusting it for your own purposes. So if you go to the template studio and click and look at the list of templates, you'll see a copyright agreement there among the list of the other ones. I think that could be a copyright license. That could be a good starting point, I think, for learning about the technology, as well as actually doing something with it, maybe creating a more detailed, robust, or tailored version of the license for your own, for let's say the specific fact pattern or needs of the parties.
Perfect. And then assuming that we're able to come up with something good, and it was good enough, so we wanted to contribute it back to the community. Where would a student or a team do a pull request, or what other action would they take to contribute it back under your license?
Yeah, sure. If you can just download the template once it's done on Template Studio, and then you'll get a file, and that file can be uploaded just by itself. It'll automatically populate the GitHub repository appropriately for the Accord project. Yeah,
it's a Apache 2 license. Is that right?
That's correct. Yes. Yeah.
That's again legit street legal recommended open source license with MIT and the others. So fantastic, another best practice. Neela, did you have a question or comment?
actually about to it, so I only have one comment. I'm amazed by how simple and approachable this technology looks. Of course, I
Great.
need to sit down on my own and try to hack some contracts, but it seems so like easy, you know, intuitive, and it's welcoming for a lawyer. You know, it's not scary at all, and invites us to think the contracts and legal procedures in another way. So I'm very happy to see that. Thanks for your time.
Yeah, absolutely. I'm glad to hear that. And by the way, we do plan to and certainly welcome contributions to help make it even more accessible, including from a user interface point of view. So if anyone has sort of front end skills they would like to add to the template studio, those are more than welcome. But in any case, you know, from the core project's existing membership, we do plan on making it even more accessible, perhaps having a specific guide for the template studio itself, just to make it easier for lawyers and others to contribute templates to make the library grow over the course of next year.
Great. And you know, one thing maybe we could work on is in our sort of general approach to computational law for contracts, statutes, and regs. We have a principle that in general, each of the key terms and the overall instrument should also have a so-called human readable, like a plain language or a plain English, in our case, version of it, sort of like the approach that Creative Commons takes and that the good law people in England have taken. So maybe one thing that we might work on over the next semester, once we get our hands on your tools, would be you know, a way to designate what the very short plain language representation of key terms in the instrument is, so that could be displayed, you know, with CSS or otherwise appropriately, along with the legal and the machine readable layers of the contract.
Yeah, no, that'd be great. I think if someone wants to, I think that'd be a great contribution. Making a plain English guide approach to this would be also helpful. We did have we've started on some of that before, but I think that for this template studio in particular, given its very graphical or online orientation, that would be really helpful too.
Okay, awesome. So I guess in closing, could you just do one more shout out for people that would like to get involved and join your, I think you've got a weekly technical committee and you've got a community list. What are the key entry points for people that want to learn more and get involved?
Yeah, wonderful. It's all available to begin with at accordproject.org. And you'll see links to the documentation, how to join the project, the Slack groups, of course, the template studio, with some introductory videos too, which I think I've sent over to yourself, Daza. And yes, the technology working group, which is most focused on these types of templating and ergo computational contracting language issues, meets every Wednesday at 4 p.m. Eastern. We'll begin again in the new year, 2019. And then the working groups meet about monthly on the specific areas like supply chain, real estate, and financial services as well.
Outstanding. So there we have it. Human Shadab, the Accord Project, smart legal contracts together at last. The smart and the legal. Thank you so much for taking the time to walk us through that. And we really look forward to seeing how this thrives and evolves through 2019 and beyond. So happy holidays to you. And thank you again for contributing to the learning at law.mit.edu.
Likewise, and thanks for having me. Have a great new year. See you soon.
Bye now.